Previously, you have used the method of initial rates to determine orders and write a rate law. Now we are going to look at graphing as a way to determine the order of a reactant. So recall that you have learned the integrated rate laws that describe zero order behavior, first order behavior, and second order behavior. These are linear equations, and we can take the data and try to fit it to these equations to see which is the best fit to describe the order. So we have an example where we have this data where the concentration has just been measured over time. So we're going to find the graph that makes the best fit. So here's that data again, time and concentration. So recall that zero order behavior follows this equation. So we need to graph the concentration on the y-axis and time on the x-axis. And so I can do that with the original data to check for zero order. And we get a graph and we do a linear fit and it looks like this. Then we need to try first order behavior. And I'm sorry if I didn't say that correctly earlier. The last graph was zero order. Now we are doing first order, and first order is the natural log of the concentration versus time. So for the concentration data, you take the natural log of it, and then you're going to graph the time and the natural log of the concentration, and you get this graph with a linear fit. And then we're going to go back to the original concentration to check for second order and do 1 divided by that concentration and graph 1 over the concentration versus time and get this graph. So the best linear fit comes from looking at R squared. The highest R squared is the best linear fit. So in this case, we find that the best fit is first order. So this reaction is first order in terms of this reactant.